Okay, guys. So, a little bit more of a podcast format here, but today we're just going to talk about different use cases for the Desmos calculator on the SAT. And so, a lot of y'all don't know what Desmos is, in some cases. Like, I feel like Desmos is used in some classes for graphing equations. And really, and actually, people who do know what Desmos is, it's mainly just for that stuff, right? But funny enough, I feel like on the SAT, now that they give it to you on the digital format, it can be used for a lot of different things. Whether that's for turning problems that are not the graphing type into a graphing type of setup where you can solve for the solution easily, but also can be used for things that are not related to graphing at all. Honestly, it's just has a lot of potential, and honestly, there's like a large percent of the test where you can use Desmos and honestly, answer those questions really quickly for yourself. Because guys, at the end of the day, like that's the big thing is I feel like the SAT is not just about like answering the problems correctly and then feeling confident in the answers, but it's also about doing it quickly too. Because for example, like, and this is one of the topics I'll talk about today, in a systems of equations problem, many of you guys at this point who have taken like Algebra 1, Geometry, Algebra 2, you've seen systems of equations. It's where you do like substitution, elimination, and stuff like that, and you're trying to find like an x equals value or a y equals value, and you could have this one guy taking the SAT in the room next to you, and maybe he or she is solving it using elimination or substitution, and they're doing all the steps correctly, and they feel really good about it. They get the correct answer. They find the right coordinate answer for it. But if you're that one person, or one of those few people who actually use Desmos and graph the two equations in a system, instead of having to go through the steps of like substitution, elimination, I guess my point is you can solve the answer that way, and really Desmos solves it for you in a really quick span of time. All you have to do is type in the equations, and you're answering it correctly just like they are, except you're taking like, about a fifth of the time that they're taking, maybe even less. So yeah, at the end of the day, there is a time limit. I know some of y'all probably have some like added time and stuff like that too, which is great. But you really ideally you want to be as efficient as possible, and Desmos is going to help y'all be more efficient without actually having to rush to be more efficient, because this is the type of efficiency we want. It's the type where you don't feel rushed, and you're also confirming for yourself that you're getting the right answer on a lot of things, because it's in a built-in graphing calculator. Okay, so speaking of, the first use case that's actually, funny enough, not quite as obvious sometimes, is because again, a lot of y'all use Desmos in class for graphing, is Desmos can just be used as a straight up calculator, right? So you can have something like, let's just say if you wanted to divide, like there was a problem where you had to divide like 10,000 by 5 or something. And so when you go to there's a little tab on your SAT screen that opens up the Desmos calculator, and so it'll pan to the calculator screen. When you see the graphing calculator screen, on the left-hand side, there are a bunch of boxes or sort of spaces for you to put equations inside. And what you can do is, yes, you can put equations in there, but you can also actually just put math calculations in there too. And so this gets to my point with the calculator bit, is you can quite literally type in 10,000 divided by 2 if you want to know what that is, or 10,000 divided by 5 if you want to know what that is. And so let's just say we go to that top box and type in 10,000 divided by 5. In the bottom right corner of that box, in the, where you're typing in the equation, it'll say equals the answer, like equals the number answer. And again, a lot of people don't know this because they use it primarily for graphing. But like I said, you can just literally use this as a calculator, and you'll see the answer of 2,000 right there. And just a note too, guys, I'm not, you can probably tell, I'm not actually doing any screen recording of problems in this. This is just more of a podcast, like kind of going over the different types of Desmos use cases format today. So in the future, though, I'll actually very near future, I'll make some screen recording examples of what I'm talking about here, so you can actually see the Desmos work in progress. But Yeah, and just know that with this using the calculator thing, you get it on both modules, right? So the old SAT had, there's like a non-calculator and then a calculator active section. You can use a calculator in the whole math section now, both modules. Okay, another type of calculation that you can do is a more complex type. So I know there are probably some of y'all in high school who maybe you're in your sophomore year, junior year, something like that. Maybe some of you take as freshmen, but high school chemistry is a pretty popular thing that you guys might be taking. And a lot of times they'll call it honors chemistry. But what you see in those chemistry classes is this unit called stoichiometry. And stoichiometry involves just a bunch of different fractions multiplied in order, in sequence. And the whole purpose of it is to convert from one unit to a different unit, right? This is just the unit conversion unit, or the subtopic. So basically, you can do those in Desmos too. So if you had to, like, let's just say if you started with milligrams and then you had to, multiply by a fraction that, gave you like, okay, like, well, there's 1 gram divided by 1,000 milligrams. And then let's just say you wanted to convert it to kilograms eventually, you would then multiply by a third fraction or a third thing, which would be 1 kilogram over 1,000 grams. You could do all of that in your Desmos calculator too. So it's not just the simple things. You could also put all of that in there in the different parenthesis groups, and Desmos will automatically run through the PEMDAS steps in the correct order to calculate your final amount of kilograms, for example, if you were converting milligrams to kilograms. So yeah, so long story short, these first two use cases, it's simple calculations, and then also the more complex kind of compound multi-part unit conversion calculations, which there are plenty of unit conversion examples that you'll see pop up on the actual SAT when you get it. So another thing is going to be typing in f of x equations, and remember that f of x just stands for y, right? So you have this is looking at like the two variable equations that I talk a lot about in other videos and courses and stuff, and the f of x is, again, it stands for y, and you might see something like f of x of 2x plus 6 or something, right? And in some SAT questions, they're going to tell you to plug in a certain x value to see what the y answer is, right? So they may say, okay, f of x is 2x plus 6. What is the value of f of 2 or something, right? And so, again, some of this stuff is pretty easy. Like, you could probably just do it in your head or write it down on paper and work out the addition, multiplication. Or what you could do in Desmos is, especially if it's like a long, complicated thing, you could, in your Desmos screen, you go to the first box and you say, okay, type out the whole f of x equals, this expression with the x in it, right? And then the coolest thing is what you can do in the second box below where you have your f of x equation written is you can say f of 2, right? So you can just say f parentheses and then with the 2 inside. And that'll give you another little sort of in the bottom right corner of that box, it'll give you the equals the number answer solution. And so this is dealing specifically with input-output values. Remember, like, x is like input, and then your f of x or y value is like your output value. And so that's another big use case with that. So again, especially I'd say if you have a complicated f of x equation, it might be nice to just put that up in the first box and then say f of 2 or f of 3 or whatever they're looking for in the second box. It'll spit out the answer within that second box. So then also, this is now getting into stuff where you're not going to see the answer pop up within the little equation box, but you're actually going to start seeing the answers pop up on the actual graph area. And this one in particular is going to have your answers pop up as vertical lines on the graph. And the thing that I'm talking about is just single variable equations, right? So let's just say you had, like a two-sided equation, equal sign in the middle, and it had any type of x in it, right? Like maybe it had, square root of x plus 2 in it somewhere. Maybe it just has like an x squared in it somewhere. Doesn't really matter what the format of x is, as long as it just has x's and numbers in it. what you can do is you can plug that equation as it's written on the question. You can plug it into Desmos, into your first box, and the solution will pop up as a vertical line on the graph. And so sometimes you might have, let's just say you get a bigger solution like x equals 50, for example. You may have to zoom out a little bit, and there's a little plus minus thing on the toggle on the Desmos screen where you can like zoom in and zoom out. So you may just have to find it, but the point is it'll always give you your answer. And what I always tell people to do is go to where the vertical line hits the x-axis and click on that point of intersection, and that'll give you the x value. And the reason this is significant is because you know, especially when you have like big complicated like square root setups and squared, whatever setups where you may have to like, foil things on both sides if you're squaring and, like trying to get rid of square roots. There are a lot of algebraic steps to that. And you could save so much time just putting it in Desmos and having it spit out the answer as a vertical line. Again, it's going on that theme of like, okay, it may be two people are getting it right, but one person's solving it the hard way with steps and, the other person's solving it with Desmos in a matter of seconds. So that's very important to know. Okay, so then another way to solve these single variable equations, if you're kind of, the vertical line thing just doesn't look as clear to you or doesn't seem as reliable, another thing you can do is, let's just say you've got like an x and numbers equation with like an equal sign in the middle. You can actually you can use two different boxes in Desmos. You can set y equal to the left side in the first box, and then you can set y equal to the right side of the equation in the second box. And so the introducing of y in this case, it creates two different linear equations, right? And so what can happen is, if we took the same equation, right, that we were, any equation that we were talking about before, if we said y equals the left side and then y equals the right side in two different boxes, instead of the solution showing up as a vertical line, your x solution will actually pop up as the x coordinate of the intersection between the two different y equals equations that you've created. And so that's just another way to solve single variable equations, is to introduce y in that sense, right? So that's a good thing to know. And also, I meant to say, Desmos is very partial to using the letters x and y. So let's just say they're using like, it's very common that in classes and on the SAT, they'll use the letter t in place of x. Make sure you treat it like x in Desmos, because if you write t in Desmos, it'll probably register it as a missing constant number. So we don't want to use t for like a variable purpose in Desmos. So make sure it's just written as x. So then another thing would be, especially with linear equations, there are some important features you want to find, right? So one of them would be like finding the intercepts, right? The x-intercept and the y-intercept. And, on paper, you would normally have to rely on like, okay, well, is the equation in slope-intercept form? Is it in y equals mx plus b form? Okay, well, plus b is the y-intercept, right? Or you would have to, but again, it has to be in slope-intercept form, right? For you to, rely on that. Also, another way to do it by hand is when you want to find the y-intercept, you plug 0 in for x, and then vice versa. If you want to find the x-intercept, you plug in 0 for y, or just scratch all that and plug it in, right? You could just say y is equal to, just put your y and x equation, the two variable equation now, into Desmos, and you can just click on where it hits the x and y axes to find your intercepts. So that is absolutely handy in that case. So then here's the biggest time saver. This is the one I alluded to at the beginning, the systems of equations where you have like it could be like a y equals this and a y equals this, or you could actually have it written in more of a standard form where it's 2x plus 3y equals a number, and you maybe have like two of those written in that ax plus by equals c format. So here's the advantage of Desmos over doing it by hand and over the TI calculator also. The problem with the TI calculator, which again, you're in most testing centers, you're allowed to bring on Saturday morning tests, you're allowed to bring in your calculator. The problem with the y equals function for graphing on the calculators for like the Texas Instruments ones is you have to have it in y equals format, right? So on Desmos, you can have it in ax plus by equals c or any other format. It doesn't matter where you put things, right? It's like you can have x's and y's mixed together in any sort on Desmos and plug those in. And then also, if you're trying to solve systems by hand, substitution elimination, it might just, in most cases, it's going to take a lot longer. And you're also going to have to rely on, not making any sign errors when you're trying to solve those problems. What you could do instead is, I guess the whole point I'm getting to here is take the two equations they give you, put them in Desmos, find their intersection point, and the XY coordinate there is your X solution and your Y solution, and you're done, right? And, this is just another example of, not only is Desmos more efficient, but it's also a great way to confirm that you got the right answer. You could even use it if you're have time at the end and checking back through your work that you did, or you could just do it from the get-go, right? So that's another big thing. And then we have to think about inequalities too. Remember inequalities, Desmos, if you click on, there's a little keyboard icon and there's a little, it has like a function icon where it allows you to click on different symbols, and it allows you to do inequalities this way. So there'll be like greater than, less than, or equal to kind of things that you'll see on there. And what it'll do is it'll automatically give you like the dotted and solid lines, and will automatically shade in like above and below in the regions where solutions are supposed to be found. And so you can solve inequalities pretty easily that way, because a lot of the time with shaded graphing solution problems with systems, with inequalities, not systems yet, with inequalities, a lot of times if you're shading a certain region of the graph just by putting the inequality into Desmos, and then they're maybe asking you for the answers like, oh, which one of these points is a solution to this inequality, it's easy to tell at that point which coordinate point would be a solution, because the coordinate point that works is going to fall somewhere in that shaded region for that inequality. And so the same works for systems of inequalities, because remember, systems means you've got like multiple equations, like 2 or 3. SAT really only does 2 equations at most for a system. But there's going to be an overlapping region of area where you can find a solution, and your point of interest is going to be just in that overlapping shaded region. And so that's why I just think it's a really good idea to use Desmos for inequalities when finding points, because otherwise you're having to like test them all out in the equations, and it just takes a really long time if you don't do that. Okay, so then next big point is going to be quadratics, right? We're finally getting into not just like the whole solving single variable equations with x squared type, but we're graphing quadratic equations, right? So it's going to be like a y equals, x squared plus 4x plus 4 or something like that, like a typical, trinomial that you may see. So, okay, the big application with quadratics is when they're, especially in a word problem context, is when they're, a lot of times they're facing downwards, like it's a downward U shape. And some of y'all who are already in pre-calc may know that as concave down. Kind of looks like a hilltop. And so the whole point of these, especially when they're derived from word problems, is they're usually looking at a scenario where you're launching a rocket or something, or maybe you're throwing like a stone off of a cliff. And it's you're throwing it up at first, and then it goes down, like falls in the water below, or like hits the ground somewhere. So a lot of times in these applications, so they'll give you the quadratic function, sometimes with the variable t, and remember you got to change the variable t into the variable x. Typically what happens with these quadratics is your a value, it's in that ax squared plus bx plus c kind of standard form for quadratics. Your a value, which is the coefficient in front of the x squared, will be negative most often, especially in these word problem applications. And basically, a lot of times what they're asking for is like you picture sort of a hill shape, and they're asking for a few things like, what is the maximum height that the rocket reaches when you launch it up, or what's the maximum height that the ball or stone reaches when you throw it up from your position on the cliff, right? And so that's involving the maximum. And the reason that's significant is because not only do a lot of SAT questions ask about it, but the maximum in a downward-facing quadratic parabola graph is where the vertex is located. And so if they were to if they were to give you one of those downward-facing, word problem with like a downward-facing quadratic, and they said, what is the maximum height? All you have to do is type in the quadratic. Again, make sure you're using the letter X. It'll show the downward U shape, and just click at the top of it. It'll automatically label the vertex, and your maximum height, or maybe it could be like maximum revenue or profit or something like that, is going to be the Y value of that top vertex point. And if they were to phrase it a different way, if they were to say, when do we reach the maximum value, or how many seconds went by for us to reach the maximum height, that's when you're thinking about the X coordinate of the vertex typically. But it's nice because you can just put it on there and just kind of click on the point and you have it. And then another use case would be for the quadratics is when you hit the y-intercept, that's typically like, could represent a, again, you can just click on the y-axis and where the y-intercept meets and see what the number is because you've graphed it in Desmos. That's going to typically tell you what was the starting height that you were at on the cliff, or before you like threw a rock or something, right? And then the x-intercept, if you go way down and find where it hits the x-axis, that'll typically tell you either how far horizontally a stone traveled, or it could tell you maybe the time that it took a rocket to hit the ground, right? Because a lot of times in these cases with quadratic word problems, the x-axis is in terms of time or seconds. So that's another big thing. Quadratics are like just a really big application on the test here. So here, the next thing when relating to quadratics is it's a typical, what I'd call a challenge problem. And so you notice, like, you guys have probably seen, for those of you who've taken practice SATs or done practice sections or have taken the real one already, towards the end of the section, they'll often put a question that talks about a parabola, and they want you to figure out the value of this y equation that hits that parabola at exactly one point. And a lot of times what I've noticed is on the SAT, they'll make the one equation will be the parabola, and then the other equation will be like y equals some letter, right? And so that letter is typically a what we call a constant, and we'll see many like constant examples that I'll work through in future videos. Constants, is, again, they represent a missing number that stays the same number throughout that whole problem. So it's not a variable, even though it's a letter. And so what you can do is think about a quadratic, right? So quadratics, when they're graphed, they turn into parabolas, which are the up or down U shapes that you see. And if you have a flat sort of like y equals a number, or y equals a missing constant number type of line, anytime y equals a number, it's got to be a flat horizontal line, right? And so when you're trying to find where a horizontal line would hit a quadratic at one point, if you were to have a U shape and then you had a horizontal line cutting through the middle of the U shape, that's hitting it at two places, right? Or what if you had the U shape up here and then the line's like down below? That's hitting it at no places, right? So that's a no solution. But the only time with a quadratic, like up or down, where you can hit it in one point is going to be at the vertex. Okay, so I guess the thing, this sort of, taking like a long convoluted way to get to this short point, but basically my point is when you see a question like that, and I've seen this one repetitively on the SAT, especially towards the end when you get to the harder problems, the only place where a horizontal constant line, y equals a number line, will hit a quadratic is at its vertex. And so y would have to equal, in that case, the y coordinate of the quadratic's vertex. They may put some other things like 2's and other, coefficients in there to like trick you, but just know that a horizontal y equals a constant line and a quadratic can only hit at one point when it's hitting the vertex exactly. And in this case, it doesn't really matter if it's facing up or down the quadratic. It just, because the horizontal line will hit the vertex at, the single point regardless. So then another thing with both quadratics and also the higher power functions like cubic functions, x to the fourth functions, is a lot of questions will ask like, okay, first of all, how many solutions does this thing have? And then they also may ask like, what are the roots, or what are the x-intercepts, or what are the zeros of the function? And the way you can find that is just like, if they just give you a big cubic or quadratic function, put it in Desmos and then see where it crosses the x-axis. The locations where it crosses the x-axis are your roots or zeros or x-intercepts. And then if they ask how many there are, just, count how many there are. So pretty straightforward there. That's a big time saver, because everyone else is going to try to factor the polynomial and try to like get all the individual zeros through like convoluted factoring means. And so you can just put it in Desmos and click on them. Makes it pretty simple. So then next thing would be, like with the quadratics and polynomials, they're going to have kind of turnaround points too. And so those are known as local maxima and local minima. And so if you have a hilltop, it's a maximum, valley, it's a minimum. Hilltop, maximum, valley, minimum. And again, you can just graph it and find where those are. And just remember, the wording is key here, because if they say, they'll ask things like this. I've seen this a lot in the practice SATs. They'll say, at which x value does a maximum occur? You have to make sure that when you click on like one of those hilltop maximums that you record the x value, if they say at what x value, or if that's what they ask for. If they ask for, instead, if they just say what is the maximum value, click on that hilltop and it's the y coordinate is your answer instead. So again, just to clarify the phrasing, if they say at which x value does the maximum occur, x coordinate is your answer, and then what is the maximum value, y coordinate is the answer. And then you can do the same with the minimum locations for if they ask for a minimum value, and those are at the sort of the valley shaped things. And again, like I said, they in class y'all sometimes call them turns, and so just look for the turns in the graphs. Okay, so this one is one of the counterintuitive uses of Desmos, because again, we kind of covered like the, solve for x, or like the find the key features like vertex or roots, or, solving for like the vertical x lines, like for, x equations and things like that. This next one is counterintuitive though, and it's really useful because I feel like there are questions on the SAT that pop up all the time that say, which of the following is equivalent to this expression? Or they'll say this expression is equivalent to which of the following? And the following is just your A, B, C, D, multiple choice answers. And this type really has to be it can't be one of those like fill-in answers. It has to be multiple choice, because fill-in answers have to be some type of numerical answer purely. And so basically like they say like, okay, which of the following is equivalent to? The problem is they don't give you instructions on how to simplify or how to turn the expression that they give you into a different form that may be listed in the answers. For example, they may give you this big written out like standard form, like ax squared plus bx plus c kind of format of quadratic. And then they say this expression is equivalent to which of the following. And then what you'll notice is sometimes maybe all your answers are in what looks like factored form. And so basically that wording of which of the following is equivalent to, that's really the same thing as saying simplify, or in the context of like if you were to look at the answers and realize they're all in factored form, that statement, that generalized statement that they gave you in the beginning could just mean factor this to find your answer, right? So maybe that's kind of the command that they're giving you without really saying it, right? So what I always do, this is where the Desmos use case comes in, is let's just say there's like a big cubic thing and written out like x cubed, x squared, like all the terms added and subtracted out. And then you have a bunch of factored form answers. And let's just say you don't feel comfortable factoring, or maybe you just kind of blank out in the moment, because again, this is what happens on test day. It's just sort of it can be a reality sometimes, as people will blank in the moment. And so what can you do instead? If you like forget all your, factoring skills in the moment, what you can do is type your original expression into Desmos in the first box. And then if you're really feeling kind of rusty with the factoring, you can just type in the different factored answer forms, and whichever one matches the graph exactly of your original equation or expression that they put in, that's got to be your answer. So if you put in your original thing, and then let's just say that you get to you're trying out all your answer options in the second box, and you get to letter C, and it perfectly overlays your original expression. C has to be your answer then in that case. So again, you would never think to, this is one of those counterintuitive things, because you'd never think to like use a graphing mechanism to solve factoring, but it's just a really nice shortcut. It allows you to just kind of get rid of factoring altogether if you'd like. So that's a great thing. It also works for synthetic division. So I'm kind of hesitant to talk about that because synthetic division is not as popular on this digital version of the SAT. It was more commonly seen on the old version, but if it does happen to pop up for whatever reason, you can type out the different synthetic division answers and see how they match your original expression that was written before dividing. Okay, so then basically, this is a really cool one. This is getting into more of the constants examples. When you're maybe there's a question that says like, okay, like a quadratic equation is given by the following format, and then it says ax squared plus bx plus c. So it has and so x is your variable, a, b, c are your constants. And then it'll give you sometimes it'll do this thing where it'll give you a list of points, whether that's in table format or maybe they just list a bunch of points out as coordinate points. And so what you can do is kind of a crazy thing. You can create, there's a little add button in the upper left corner of Desmos, and you can actually create an XY table. Or you could do X and F of X as your column labels too. But you can create a table of those points and just put all your X coordinates in the X column and then all your Y or F of X coordinates in the second column. And then there are a few more buttons. And again, I'll demonstrate this in screen recordings in the future, but there are some buttons that you can click that allow you to create a type of function regression. And so let's just say, in our example, we're doing a quadratic regression. You can click the quadratic regression option, and what it'll do is it'll create the quadratic equation that matches these points. And what's nice about that is it'll just give you, like, let's just say you, make the table, put the points in, you click the regression button, you choose the mode to be quadratic regression, it'll spit out your equation in the ax squared plus bx plus c format. Maybe it's like 2x squared plus 5x plus 7 or something. What's great about that is you've now found a, b, and c automatically just by doing the quadratic regression. And a lot of times they'll ask something, at the end, like, oh, like what's a plus b plus c once you found it. And so then you can go, okay, well, A was 2, B was 5, C was 7. So 2 plus 5 plus 7 is 14. And that'll be one of your answers. And so it's a really nice way of using regression modeling on the Desmos calculator to just find those constants instantly for that function type. And then also, I'll get more into this when I show examples, but when there is an equation with sliders, when there's an equation with constants in it, you can type the constants in, like, let's just say, let's just say your variable was X or something, right? And maybe another variable is Y, but then they include a constant called K, right? You can type those equations into Desmos, and like I said, I'll go into more detail on screen recordings, but when you type in a letter besides X or Y, Desmos will automatically, in most cases, pick it up as a constant, and they'll give you what's called a slider option. And so it'll say, give you this little button to press that says add or create slider, and you can press that. And what's nice is sometimes when they're, let's just say they're trying to find a constant that like makes the left side and the right side of an equation equal or something. Once you have the slider built for that constant, and then you have all your answer options like A, B, C, D, right? You can start plugging in those different options in for your K value that's on Desmos now that's been given a slider, and one of those is going to work, right? Like one of those constants is going to work, and it'll show like it'll show the left side equaling the right side. You could do it with systems too. And again, little vague here because it's better to show it, but using the slider for constants and being able to just plug in and try out your multiple choice answers to see which one works is just a huge, huge advantage. You don't actually then have to go and solve for your constant. And because I know a lot of you, just from personal experience, I've had a lot of students just kind of lament about having to solve for constants by hand. So more to that when I do the demonstrations. Okay, the few more here at the end. So there is the circle equation, and this relates to the geometry topic, but we're not really covering the thing that I'm talking about with circles here in terms of Desmos is not really the type where you're looking at like circumference or area or sector area or, arc length, stuff like that. I'm more so talking about the algebraic method of expressing a circles equation. And so that's that format. The y'all have probably, especially the people who are in have done geometry or are in algebra 2 or beyond that, have probably seen the circle equation. It's x minus h quantity squared plus y minus k quantity squared equals radius squared. And a lot of times they'll just give you those numbers for that, and they'll say, maybe they'll give you a circle equation with numbers plugged in, and they'll say things like, hey, what's the center, or what's the radius, or what's the diameter. You can just type in the circle equation with the numbers for the center and everything into Desmos, and from there, it's pretty easy to see where the center point is, because the center point is going to be in the middle of the circle, and it's going to be, let's just say we have a center, maybe we have a circle with a radius of 3, for example, right? The center point is going to be 3 away from the right side of the circle, 3 from the left, 3 from the top, and 3 from the bottom. And so it'll be easy to tell where the center coordinates will be located. And also, a lot of times with circles, they'll make it easy for you to click. The Desmos will automatically make sort of clickable points on the top, bottom, left, and right sides of the sort of points of the circle. And that way you can kind of, like, if you do the top and bottom ones, you can just get the difference between the y values of the top and bottom points, and that's your diameter. And then if they said, oh, what's the radius, you can just cut that distance in half and find the radius that way. So again, like circles, a lot of those you can just plug into Desmos, even if it's in the general form, not the circle equation form. You can put it into Desmos and just find all the key features that way really easily. All right, so we have 2 more points. So one of them is, you can plot points to, let's just say they are giving you a problem about a like a triangle setup or a different shape, and they give you like 3 or 4 points, right, for a triangle or a square or something like that. Well, let's just say there was you wanted to know whether it was like a right triangle or, some other type of like scalene triangle or something. You can plot the points in Desmos, and I'll show you how to do that in demonstrations. That way, let's just say you had 1 point up here, 1 point down there directly below it, and then there's another point directly to the side of the bottom one. You'll immediately be able to tell without having to visualize it that it's a right triangle, because you have a side length that would connect those 2 points going straight up and down, and then a perpendicular and horizontal side going that way, right? And then you have that hypotenuse connecting the 2 far away points. And so that is just really great for formatting the way that, it's like if they just give you points and you want to know what the shape looks like, just for your own personal convenience, you can plot points and sort of visualize what the shape looks like more easily in that case. This last one, and again, there's plenty of other tricks that I want to go over in the future too, but I'm just kind of covering some of the main key ones here. This last one for today is the transformation of functions trick, where and you guys have probably seen this, especially if you're in algebra 2 and or in pre-calc. Transformations of functions involve when you're shifting a function to the right or left or up or down, or maybe you're stretching it vertically or horizontally. So on the SAT, they really only focus on the left-right shifts of functions, or the up-down, where if you're shifting a parabola to the right, like maybe you have it here and then it goes like this way or this way, right? So what you can do is, if they wanted to know like, let's just say they gave you like an f of x equals, x squared plus 5x minus 14 or something, right? And so then they're like, okay, here's this original function, here's f of x. Then they ask, what is the vertex, or find the y value of the vertex of f of x minus 4. And so you have like an f with an x minus 4 that's in parentheses after it. And what that x minus 4 means is, if you knew transformations, you would know that means that you're shifting the function, the original parabola function, to the right by 4, because you have x minus 4 inside your parentheses. But what if you're kind of earlier on in math and don't know that? Well, what you can do is you can, in box 1 on Desmos, you can say f of x equals x squared plus 5x minus 14, right? And then in box 2, just say this, f of, with parentheses, x minus 4, and then close parentheses. And it'll automatically show you the shifted to the right version. You'll actually see the U-shape shift 4 spaces to the right. And then if they're like, they want to know about the vertex in this case, just click on the vertex and you'll have the x coordinate and the y coordinate, and likely one of those will be your answer, or the entire coordinate will be your answer. So that's just an example of function transformations. You can do them without even knowing what they really are, which is kind of great. So that, honestly, that wraps up the main stuff. I'll go into the niche details later and the demonstrations of these things with, like problems that are close to real SAT problems. And you'll all see it in action in the future, and more of the final, I guess like the final sort of levels of things you may approach in math in this sense. Desmos is a great shortcut tool, and I think it's going to accelerate your problem solving in a big way. So until next time, see y'all.